Welcome back to CS270. Sorry about the missing videos for last week. I had some problems with my recording software, but it looks like everything is working now. So let's take a look at one of the things from last week that's still not due quite yet, which is Lab 2. So this is an assignment about writing a program to make a directory listing. Uh, so if I run ls in my current directory, I'm using -a here, which means show all files, even hidden ones. Hidden files start with a dot. And I can see this directory currently has two things in it, dot and dot dot. If you looked at the slides from last week, then you saw that in the Unix file system, dot refers to the current directory, dot dot to the parent directory, the one that contains that. So here I am under my home directory, lab2. So dot refers to the lab2 directory, dot dot refers to the lab directory. Well, I don't have any files here yet, but if I make one, the touch command creates a file, or if it already exists, updates its timestamp. Then ls-a will show three of them. So we're going to write a program that works kind of like this, with a couple of differences. For one, we're not going to do this color highlighting that puts my directories in blue and executables in green and so on. For another, we're going to list the files one per line. And actually, if I add the command line argument 1 to ls, then it will do pretty much the same thing as our program, again, other than the color. To do this, we're going to need a couple of library functions. So let's take a look at the first one, man opendir. So opendir is used to open a directory, kind of like we would open a file, except there are different things we can do with the directory compared to a regular file. So to open a directory, I have to give the name as a C string, and that will return to me something called a dir star, a pointer to something. This is what's called an opaque type, meaning I don't actually know, and I shouldn't care, what is in a dir. I shouldn't be dereferencing the pointer I get. Rather, I'll use it by passing it on to other functions. So one of the other functions I need will be readdir. Readdir takes that directory pointer, reads the next entry from it, which will list one of the files that's in that directory, and returns a pointer to a struct dirint. And unlike this dir thing, a struct dirint is something that's defined. These are the various fields we have in it. So I have an inode number, and something else that is not an offset, the length of the record, which is mostly needed if I want to do some dynamic memory allocation, the type of file, so this would be something like, is it a directory? Is it a regular file? Is it a device file? And the name of the file as a character array, which will be null terminated. And then the final thing that I'll need for working with directories is, just like when I open a file, I should close it. When I open a directory, I should close it with closdir. So I'm going to need to use these three things, but I also am going to have to do a little bit more work. If I'm dealing with system calls or library functions like these that could fail, it's always a good idea for me to handle that. As an example with ls, if I make my current directory inaccessible, and then I do ls-a1, it's not just going to report nothing or crash, it's going to give me an error message telling me what the problem is. It can't open the directory dot because permission was denied. So this first part, ls cannot open directory dot, this is generated by our program. We as the programmer will write out that message. But then this part, permission denied, that is a standard error message. and we'll see in a minute how to get those. All right, so let me change my directory back. 755 here means read, write, and execute for myself, read and execute for the group, read and execute for everybody else. I am going to have to go to a different directory to do that because, of course, I can't refer to dot. CD minus will take me back where I was, and my directory is fine again. Let's remove this test file. Okay, so I'm going to create some code, and we'll get the directory stuff working. So I'll start with, I could do this in either C or C++. I'll go with C since it's a little bit simpler, but doing this in C++ would work just as well. So I'm going to call my program dir.c. So first thing I'm going to need are my header files. Well, which header files do I want? Let's take a look at those man pages again. So man open dir. At the top of each man page about a library function or system call is a list of the headers that I need to include to use it. In this case, I need two. I need dirint.h, which is a header file that defines opendir. I also need sys/types.h, which may be what defines dir, for example. So coming back to the editor, let's include sys/types.h, include dirint.h. Let's start main. This program doesn't need any command line arguments, so I'm not going to write those in. If this were C++, I could have just left these parentheses empty, but in C, I have to explicitly write void to have a function that takes no parameters. So opendir returns a dir star, so I'm going to need to make a variable for that. I'll call it directory equals opendir. And in this program, I'm just going to work with the current directory, dot. So now, what if opendir fails? And how do we know whether it failed or not? Well, opendir returns a directory pointer, and according to the manual page, well, don't just take my word for it. Every manual page has a section called return value, which is what the function returns. Usually, if there's an error, that will be indicated in the return value. Also, this section errors, that is a list of the different kinds of errors there might be. So the opendir and fdopendir, we're not using fdopendir, functions return a pointer to the directory stream, that dir star. On an error, null is returned. Okay, that tells us what we want, and error_no is set appropriately. Error_no is a global variable that stores the code for the error. We're not going to use it directly quite yet, but we'll use a library function that works with it. So, if my directory was null, so I could write it like this. I could also say if not directory with an exclamation mark. A null pointer, when treated as a Boolean, is false, and all other pointers are true. So that means that opendir failed, and I should make a message about that and end my program. I don't want to keep going and try to do readdir on this null pointer. That would probably crash. So to make the error message, there's a library function called perr. I give it in quotes or as a C string the part that I want to come before the colon. If you remember that error message from ls, I'm going to give it this part, and it will display that, a colon, a space, and then the string corresponding to that global variable error_no that I mentioned. So, I think this would be a reasonable error message. If my program were such that I might be looking at different directories rather than just dot, I might want to do something to get that directory name in here. But for now, this is sufficient. And I want to exit the program. We'll see a little more about exit in a later class, but the exit function, you give it one argument. That's going to be the exit status return value, essentially, for the program, where 0, oddly, indicates success, and anything non-zero indicates an error. The idea behind this is that there are many more different ways to have an error than there are for everything to work correctly. So we can have different non-zero codes indicating the different errors we might have. We'll just use one everywhere, though. Now, exit and pierre are themselves library functions. I need to include the correct headers for those. So man p-error tells me I need stdio.h, and man 3 exit. I'm specifying the 3 here because there are other things called exit, and I want the one from section 3 library functions of the manual. And to get that, I need to include stdlib.h. All right. So now I have either opened the directory or failed to open it, reported an error, and exited. So at this point, I know that the directory's good. That second function that I want to call is readdir. I give readdir this directory pointer, this thing, as its argument, and it will return a pointer to a struct dirint. I'm going to need to do this in a loop because I want to get every directory entry, not just the first one. So I can do that by writing a while loop. But before I start the while loop, I'm going to need a variable to hold my pointer. Struct dirint star, I'll call my pointer entry. And up at the beginning of my program, I'm not going to initialize it. That'll happen here in my loop. If I were writing this in C++, I would want to put this line just before my loop so its scope is as small as possible. But in C, all my variable definitions for local variables have to come at the beginning of a block. So I couldn't put it here after the if because that's not the beginning of any block. I could put one inside my while loop, but well, it turns out I'm actually going to need to know what the return value was in the condition of my while loop, so that would be too late to define it. So now I can say while readdir directory, but of course, or even while it's not equal to null. Readdir also, like most functions that return a pointer, returns null if there was an error. Also, it returns null if there weren't any more directory entries, if I already read them all. So the problem with this is I did read from the directory and got the next directory entry, but I threw it away. Well, it turns out in C, assignment is just an expression. I can use it as part of a larger expression. So I can say something like this. So this says, while this whole expression is true, so working from the inside out, read the directory, store that in entry, and as long as entry is not null, repeat the loop. So every time the loop repeats, it will read the next entry, store it in the pointer in this variable entry, and check to make sure that wasn't null. All right, so now that I'm inside the loop, I know that readdir succeeded and it gave me something that wasn't null. So I want to just print the name of the file in that directory entry. So I can use whatever I want to do the printing. I'm going to use printf. And the thing I'm going to print is a C string, so %s, that is a pointer to a null terminated character array, followed by a new line. And the thing I want, well, let's go back to readdir. That's going to be d_name. So my struct dirint has a member d_name. Entry is a pointer to one of these structs, so I need an arrow instead of dot, d_name. All right, so there's a bit more to do, but let me test what I've got so far. I should, by the way, make sure I have the header files for readdir and printf, but it turns out I do. I have dirint, I have stdio, so we should be good there. So going back to the command line, I'll compile in one step, run my program, and it gives me a listing. So far so good, but there's still a little bit more I need to do. Namely, I got out of this loop because readdir returned null. That could mean that I got all the way through the directory listing and there weren't any more files, but it could also mean that readdir had some kind of error. So I need to check that. The problem is readdir's return value doesn't indicate which of those happened. Instead, I need to use that global variable I mentioned, errno. At the beginning of the program, before main starts, errno is always initialized to 0. And then when a library function fails, it sets errno to some non-zero value. If a library function succeeds, it doesn't reset errno to 0. It leaves the error there. So if errno, when I get to this point in the program, is non-zero, that means that either opendir failed, or readdir failed, or theoretically printf failed. I know opendir didn't fail. I already checked for that. I'm going to just assume that printf isn't going to fail. That might not always be a good assumption, but if printf failed, I'm probably not going to be able to produce an error message anyway. So that means if I get to this point and errno is not 0, then it must be readdir that failed. So I can say if errno equals 0, but there is still an issue, which is errno is another thing I need to include a header for. So let's do man errno. So it's in section 3, even though it's not a function, it's a global variable. But I need to include errno.h. I can also read in this manual page more about errno, exactly how and when it's set, some or many of the error names, as well as the message that corresponds to those. And you can see there are a lot of them. Every system call and most of the library functions that can fail will set errno to one of these things, so we need error codes for every possible way something like that could fail. So I do need to include errno.h. And if readdir failed, well, I'm going to do almost the same thing I did before, except change my message to indicate which function it was that failed. In a more user-facing program, we'd probably want this message to be something less technical, less about the exact function that we were calling, and more about what the program was trying to do. That said, here, the whole point of this program is to test and use these functions, so here it's appropriate to give the function name. All right, and that's almost everything. There's one more function I need to call, which is closedir. Closedir, I give it the same dir star that I had before, and it will close it. It's possible that closing it has an error. Man closed dir. Closed dir function returns 0 on success. On error, -1 is returned, and error no is set appropriately. Now, it turns out there aren't many reasons that closing a directory can fail, at least on our Linux systems. That would really only be if the thing I passed it in was bad. And I have, well, checked that it's not null at least, and I would hope that it's not bad. But just in case something weird went on in our program, we probably should go ahead and do the check. Now here, I'm not going to look at error no, because I can just check the return value. If closed dir of the directory is not equal to 0, I could also say if it's equal to -1 or if it's less than 0. But if it was successful, it returned 0, so this means it wasn't successful. And again, the same kind of error message, but I want to specify which program it was that failed. All right, so with that, I need to do a little bit of testing, but I'd be ready to add my header comment. Today's date is 2020-04-05. Let me save my program and run GCC again. Run it, and oh, I seem to have done something wrong. Read dir failed. Success. Let's take a look at dir.c. Aha! Well, notice the message. Read dir failed. That was the thing I gave in my p error, :success, meaning it didn't fail. That's what p error produces when error no is 0. And if I look at this line, I can see if the error number is 0, meaning there wasn't an error, I print an error message. And if there was an error in read dir, then I don't print one. So that's backwards. We'll fix that. Run GCC again, and run my program. Now, if you compare that to what I showed before, you can see the files are in a different order. Well, it turns out ls doesn't just list the files, it sorts them. If we wanted to sort our directory listing, well, we'd have to use a library function or write our own sorting algorithm or something along those lines. That's outside of the scope of this assignment. It turns out with ls, if I give the -U option, that tells it not to sort, to show the entries in the order that read dir returned them, and you can see I got the same thing. Now, what determines this order? That's really unspecified. It's up to the file system, the way that it stores directory entries. It could be that it's from oldest to newest, although that doesn't seem to be the case. Dot existed before I created dir.c. It could be that this file system always puts dot at the end. It could be something else. That's kind of one of those implementation details of the system that isn't specified and can in fact differ from one system to another. If I were using a different file system on this computer, then I could get an entirely different order. So with that, I think I am done. I will take this file, upload it to Canvas, and then I'll get credit for the assignment. So if you haven't finished up the program yet, you still have a chance, so get that in, and I will see you soon.